Hello there, welcome to the June 2018 paper. Here we're looking at question 4. So, part of the mains water system for a housing estate consists of water pipes buried beneath the ground surface. The water pipes are modelled as straight line segments. One pipe W is buried beneath a particular road. With respect to a fixed point O, the road surface is modelled as a plane with the equation 3x minus 5y minus 18z equals 7, and W passes through the points of A and B. The units are in metres. Use the model to calculate the acute angle between W and the road surface. So this question here is effectively find the angle between a plane and an intersecting line. So let's just draw our little model of this here. In this question here, we need to know the n vector of the plane, and the n vector is just going to be the coefficients of the plane. So 3 minus 5 minus 18. We also need to know the direction vector of the line. So that's the direction vector from A to B. So let's work that out. How do we get from A to B? Well, let's look at it. From -1 to 1, we go up 2. From -1 to 2, we go up 3. And from -3 to -3, we don't go up anything at all. So it's just 2, 3, 0. Now we need to work out the acute angles between these two lines here. So then, after that, we can then work out what the angle is between the line and the plane. This is our final answer here. But first of all, we need to work out what alpha is. And we work out alpha by doing the dot product rule. So it's going to be A dot B equals mod A mod B cos theta. Or in this case, it's going to be cos alpha, because I'm working out this angle here first. So A is going to be 3 minus 5 minus 18. B is going to be 2, 3, 0. Then it's going to be the modulus of A, so 3 squared plus 5 squared plus 18 squared. I dropped the negatives here because we're going to square it anyway, so it's not needed, times the modulus of 2 squared plus 3 squared plus 0 squared, but I don't need to write it, times cos of alpha. So let's now work this out. So let's grab a calculator. It's going to be -9, and then we'll divide by these two square roots in one big go. So it's going to be the square root of 358, and the second square root is going to be 13. This will equal cos alpha. So therefore, cos inverse of this answer all in one big go will give us 97.58. Okay, so our diagram's not particularly accurate here because I've got my diagram being an acute angle here. So it's not going to be this side of the line here. What I've actually calculated as 97.8 is going to be this line round from here to here. That's 97.58. So now what I need to do to work out this, just this bit of the acute angle here, is I just need to now do 97.58 subtract 90. So 97.58 minus 90 is 7.58 degrees. So there we are, that's the answer for part A, 7.58 degrees. Let's now move on to part B. So a point C with coordinate -1, -2, 0 lies on the road. A section of the water pipe needs to be connected from W to C. So this kind of question here is a very similar question to, we have a straight line, we have a point, and using the model, find to the nearest centimetre the shortest length of the pipe needed to connect C to W. So we need to connect C to W there. So coordinate C is -1, -2, 0. Let's write that on. This point here, the point at the start of the line W, I'm going to use as -1, -1, -3. And then W has the direction vector 2, 3, 0. So it's going to be a question of working out this distance here. So this is the distance D. This is going to be at a right angle to the line W. And the way I'm going to approach this problem here is by connecting C and point A together, working out what the angle here is and what the distance on this side length is, and then doing a bit of right angle trigonometry to work out what the value for d is. So the first thing I need to do in this problem here is work out what is the vector from A to C. So from A to C, on the x variable, I go up none. I go down by 1 on the y variable, and I go up by 3 on the z variable. So therefore, the distance from A to C, effectively the hypotenuse on this triangle here, is going to be the square root of 1 squared plus 3 squared, which is the square root of 10. So the value on this hypotenuse length is root 10. The next thing I need to now do is work out what the angle is between these two direction vectors. So that's going to be the dot product rule. A dot B equals mod A mod B cos theta. So A is going to be the line from A to C, and B is going to be the direction vector of the pipe. So it's going to be 0, minus 1, 3, dotted with 2, 3, 0. And that's going to equal the modulus of the first vector, which is 10, times the modulus of the second vector, which is 13, times cos theta. Now if we do the dot product here, we're going to get minus 3 over root 10 times root 13. And if we do that on the calculator, and we do inverse cos of it, we're going to get the angle of, let's just do that on the calculator now, inverse cos, fraction button, minus 3 over the square root of 130, which is 105. So 105 degrees, what that's probably referring to is this angle round from here to here. That would be the 105 degree angle. So actually the angle inside here is going to be 180 minus that value, which will be 74.7. Okay, so we just had to do a little 180 minus it, because this angle here was our 105 angle, so it's 180 minus it to get your acute angle. Now we're going to find the opposite side on this right angle triangle here. Effectively, if we draw out just the detail we need, we have root 10 on the hypotenuse, we have an angle of 74.7. We now need to work out the opposite side D, so this is going to require just a bit of right angle trigonometry. Sine theta equals opposite over hypotenuse, so therefore it's going to be sine of 74.7 equals the opposite side, which is D, over root 10. And then if we do sine, I've got 74.7 in my calculator, so I'm just going to do 74, so it's sine of answer button, and then multiply that by the square root of 10, and I get an answer of 3.05. So 3.05. Now to the nearest centimetre, this is in metres at the moment, so the distance here is going to be 305 centimetres. And there we are, that's the answer for this question here. That's a 6 mark for part B, 11 marks in total for question 4. Let's now move on to question 5.